Good afternoon, everybody. Am I audible to all? Good afternoon, everybody. Let us start with the session today. Let's start with the session. Session चालू करते हैं, सब आ गए हैं. So good afternoon, everybody. Let us start with the session. Everybody is there. So today we would be doing certain good questions on PYQ. We will be revising steel structure through PYQ also. So this is the PYQ revision. Everybody is there. Let us start the session then. Let's start the session then. Yeah. So yesterday we have revised the steel structure. Today we will see certain important questions that were being asked in your exam. Let's start with the discussion then. Let's start with the discussion then. Okay. Everybody please reply. So let me put on this YouTube Unity here so that your options I can get here. Okay. Yeah. Now it's on. Okay. Very good. Let's start with the session then. Let us start with the session. Good afternoon, everybody. So are you ready for the first question? Are you ready for the first question? सब लोग आ गए? Everybody is here. Everybody is here. Let us start the session then. So yesterday we have revised all these topics once. In the Maha revision we have seen the revision of plastic analysis, bolted connection, welded connection, tension member, compression member and beams. In this I have told you the most important one is the plastic analysis. Then the importance order is decreasing. Okay. Then lesser important will be bolted and welded connection, then more less important is tension, compression member and so on. But most important of all is the plastic analysis. Every year at least a question can be expected on the plastic analysis. Okay. So in GATE generally 2 to 4 marks questions are asked from this topic. In GATE generally 2 to 4 marks questions are asked from this topic. So let's start. Let us start with the first answer. So just you have to type the answer in the comment box. I will get it in the polls. Okay. So start with plastic analysis. Start with this question. So here you have to report your answer in numerical type answer, but you will report your answer in nearest value of integer. Okay. Let me see what was the answer. Yeah. Report your answer in the nearest value of integer. Rounded off to the nearest integer. Okay. So rounded off to the nearest integer. Round off your answer to nearest integer. Okay. I am waiting for answers. Please start. So first we are doing plastic analysis question. Very good question. I am giving you 4 minutes time. Try to solve this. Make it fast please. हो रहा है सॉल्व आप लोगों से? try it, make it fast please. Shape factor, you have to calculate the shape factor. Here elastic section modulus was given to us. So first of all, try to calculate the equal area axis position, okay, then only you would be able to solve it. First of all, try to trace the equal area position here. Let me also start solving with you so that we can finish it off. It was asked in 2024 last year only, okay. Very good question, but let's try to solve this question for you. Let me try to solve this question for you, okay. Okay. First of all, let's try to trace the, Yusuf, report your answer in nearest integer, then only we would, it will pick up your answer. Rest you can report the exact answer also up to 2 decimal place. Few students are there, so I can just see your typed answer as well, okay. So you can type your answer up to 2 decimal place also here. So first we should trace the equal area axis. See how to trace the equal area axis. What is given to us? A steel angle section shown in the figure has elastic section. ZE was given to me. ZE is 150.95. Sorry, 150.92 centimeter cube. So first of all, we will have to, and we have to find out the horizontal axis, that is x-axis is passing through the CG of the section. So this is the CG of the section, okay, but I am not interested in the CG here. I am interested in the equal area. The shape factor of the section is. So first you will have to calculate ZP. Once we know the ZP, you can calculate the shape factor. We have to calculate the shape factor here. That is the ratio of ZP upon ZE, okay. So just you have to calculate ZP. Once we know ZP, we can calculate this shape factor as well, okay. This is my main aim. First we will have to see the position of equal area axis. See if you can see here, the total area of the section is how much. What is the total area you have calculated? Now please tell me the data one by one, all the data also please post here. Post the data also, my dear friend. So first of all, tell me what is the area you are getting here. What is the area? Area is how much? 15 minus 3, that is 12 into 3 and 12 into 3. Okay, this will become very simple now, because this much distance is how much? This much distance is how much? 15 minus 3, that is 12 centimeter only. So equal area axis is this one only. Directly I can say that this is my equal area axis. And total area will become how much? 3 2s are 6, that is 72 centimeter square. That's correct, okay. And equal area axis, directly I can say this is half area, this is half area. So observe also the figure, you should observe in the exam. Directly I can see that this is the equal area axis. Now we have to calculate ZP. ZP I know is equal to what? A by 2 into y1 bar plus y2 bar. See, y1 bar CG of the first area will be at a depth of Z by 2 is how much? 72 by 2. Y1 bar is how much? 12 by 2 plus its CG is 3 by 2. So ZP how much you are getting? Tell me fast. What is the value of ZP you got here? ZP is 270 centimeter cube. I got ZP as 270 centimeter cube. Okay, correct. Now shape factor is, see, very simple. These kind of simple questions are asked from this topic. So don't worry, in the exam you will generally get very simple questions only. So my shape factor becomes how much? That is 1.789. That is 1.79. Okay. You will get it as 1.789, but we had to round it off to 2 decimal places. So correct answer will be 1.79. Would have been the best answer. I can see Yusuf was the first one who have reported the answer, then Anant, Manoj, Shushmita and so on. Got my point? Let's see the next question then. Are you ready for the next question? Again, one more question I am giving you on shape factor as well as MP. Try to attempt this as well. Try to give me the correct answer. So, 2 would have been the nearest integer. Just you can type the answer. Okay. So, it's a MCQ type question. So, please try to solve this one as well. You have to find out MP as well as the shape factor. So, please do it. Try to solve this question, please. Try to solve it, please. Try to solve it, then I will proceed further. See, for diamond section, I already know what is shape factor. Just you have to calculate MP. Either calculate MP directly or calculate MY. From there, you can calculate MP. Try to solve this question. I am waiting for answers. Okay. I am waiting for answers. Try to solve this question. Very simple. See, shape factor here is 2. I don't need to calculate this. Shape factor is not needed. Shape factor is 2. I already know. Okay. For diamond section, shape factor is 2. Do I need to prove this? No, no. Okay. shape factor is 2. So either answer can be A or C, B can't be the answer. For diamond section, shape factor is 2. Now we have to find out MP of the section. MP I can easily find. MP is equal to what? Fy into ZP. ZP is equal to A by 2. Y1 bar plus Y2 bar. A by 2 is half of the area of the square. And Y1 bar is this one. This is my Y1 and Y2 bar, okay. That is depth of the CGL. See, Y1 bar, Y2 bar will be how much? See, this one will be how much? That is A by root 2. I can say this height. So, this is A root 2 by 3. Both will be same. That is A by root 2 into 3 plus A by root 2 into 3. Put everything, find out the value of ZP here. Then proceed further. Okay. Put everything and find out the value of ZP here. A is how much? 100 mm. Okay. So A is 100 mm here. So A square, that is 100 square divided by 2 into A root 2, that is 100 root 2 by 3 is equal to how much? And MP will be equal to Fy into Zp, that is MP will be Fy is how much? 250 MPa. 250 into 100 square by 2 into 100 root 2 by 3. Any problem till here? This will come out in Newton mm. Convert this in kilonewton meter. So convert this in kilonewton meter by just multiplying it by 10 to the power minus 6. So just tell me the answer, how much you got. Okay. So what answer I got here? I got the answer as 58.925. Like this only you did it. See, so much simple question. Just you have to calculate MP. Shape factor I already know. Okay. So like this you can solve the question. It was not a difficult question. The best answer would be what? Best answer would have been C here. C here is the best answer. Many of you have given me the correct answer. Very good. First one of you was Manoj. Very good. Then Nitin, Yusuf, Shushmita and so on. Very good, beta. Let's proceed further now. Let's proceed further now. Let us see further. Next question. Are you liking the questions? Next would be on static and kinematic method. Try to do this question. These kind of simple questions are asked in plastic analysis in your exam. Try to attempt this question. Make it fast, please. Okay. करिए जल्दी। हेलो, तो भाई स्टार्ट करें। डी वॉज द करेक्ट आंसर। तो सबने प्रेम से सॉल्व किया, काइनेमेटिक मेथड लगाया होगा जल्दी से और सॉल्व किया होगा। अरे भाई दोनों से सेम ही तो आंसर आना चाहिए। यूनिकनेस थ्योरम क्या बोलता है कि द लोड, द कोलैप्स लोड विल बी द सेम फॉर द बोथ, तो एमपी वुड आल्सो बी सेम फॉर बोथ। तो कोलैप्स काइनेमेटिक मेथड से आंसर निकालो और दोनों इक्वल होना चाहिए। क्लियर है कि नहीं? हिंज कहां बनेगी? एक ही हिंज बनना था। द हिंज विल फॉर्म अंडर दिस पॉइंट लोड, पी के नीचे हिंज बनना है। ये थीटा दे दो, प्लास्टिक मैकेनिज्म के टाइम में यहां थीटा दे दो ये थीटा दे दो, ये थीटा दे दो, यहाँ पे एमपी, यहाँ पे एमपी, और सॉरी ये थीटा फाई हो जाएगा, वेरी सॉरी, अलग अलग है ना, फाई हो जाएगा ये, और ये मेरा L/3 है शायद, और ये 2L/3 है, वेरी गुड। तो भाई एक तो इसके बीच में कॉम्पैटिबिलिटी इक्वेशन लिख दे, थीटा इंटू L/3 इज इक्वल टू 2L/3 इंटू फाइव, दिस इंप्लाइज थीटा इज इक्वल टू 2 फाई, क्लियर है। नाउ P इंटू L/3 थीटा इज इक्वल टू, भाई क्या क्या भाई, एमपी कैलकुलेटेड फॉर द कोलैप्स मैकेनिज्म, एमपी निकालना है, तो भाई दो ही एमपी लेना है, एक एमपी थीटा प्लस एमपी फाई, फाई इज थीटा बाई 2, तो P इंटू L/3 थीटा इज इक्वल टू क्या कर दूंगा, 3MP थीटा बाई 2 है ना, क्योंकि ये थीटा बाई 2 हो जाएगा तो 3MP थीटा बाई 2 हो जाएगा, तो MP कितना आ जाएगा बताओ भाई जल्दी से, MP विल कम आउट टू बी PL/9, 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 2PL/9 आना चाहिए ना, गलत कैसे कैलकुलेशन, और सॉरी 2PL/9, ये 2 भी तो ऊपर जाएगा, MP विल बी इक्वल टू 2PL/9। इसे बिना सॉल्व किए भी मैं आंसर क्लिक कर सकता था, क्योंकि दोनों के लिए कोलैप्स लोड तो सेम होगा, चाहे स्टैटिक मेथड से करो चाहे काइनेमेटिक मेथड से करो, यू वुड गेट द सेम कोलैप्स लोड, सो एमपी वुड बी द सेम देयर, बिना सॉल्व किए भी मैं आंसर दे सकता था, दैट वुड बी डी ओनली। एमपी मेरा ये है, चाहे काइनेमेटिक मेथड से निकालते चाहे स्टैटिक मेथड से निकालते, वो सेम ही आता। डी वॉज द करेक्ट आंसर यार माई डियर फ्रेंड, डी वॉज द करेक्ट आंसर, सो डी वुड हैव बीन द करेक्ट आंसर। ओके, सो you could have solved the question like this. Okay, yes, just without applying any method you could have given the answer. I am saying this, Mr. Purohit, you are very correct. Manoj, Ravi and so on, just by seeing the option also I could have clicked the answer to be D, because the collapse load will be the same for kinematic as well as the static method. So only D is the correct answer. Okay, by both the methods MP would come out to be the same. Very good. Next question we have to do. Next you have to find the value of alpha here. Please report the value of alpha. You have to report the value of alpha, report your answer. Integer only will come, so answer would be in integer. Report your answer. Let me see how many of you have given, how many of you will give me the correct answer. Okay, please solve it. Clear है? करिए जरा इसको. Please try to solve this question. So you have to find out the collapse load here. So for collapse, two hinges will be required. One will form under the point load and one at the fixed end. So these kind of simple question you can expect in your exam. Just apply the kinematic method. Report your answer. One hinge will form here, one under the point load. Okay. Point load is at L by 2 only. Very good. Point load is at L by 2 only. So here two hinges are required. One will at the fixed end and one under the point load. Okay. This is my P. So if this is theta, this will also be theta because this is L by 2 and L by 2. Got my point, my dear friend? And this is theta, theta. MP is same throughout the beam. MP is same throughout the beam. You can see load was placed at midspan. So 1 MP would be here, 1 MP here, 1 MP here. So by principle of virtual work, what I can write, that is P into L by 2 theta is equal to 3 MP into theta. Theta theta cancels. So P is equal to what? 6 MP by L. This implies therefore alpha is equal to how much? Alpha is 6. So these kind of simple questions are asked in your exam. See, you can see these kind of simple question anybody can solve, and you all are solving the answer, giving me the correct answers. Very good. 6 was the correct answer. So those who have given me 6 as the answer is very correct. So I can see 85% of you have given me the correct answer. Mr. Purohit, Yusuf, Anand and so on. Got my point? Like this you can solve this answer. MP is 6. Ravi, MP is 6, not 8. What mistake you have done there? Okay, so this kind of simple questions are asked from this part. One last question on plastic analysis, then we will see the rest part. Solve this question as well. You have to find out the plastic section modulus up to 1 decimal place about the weaker axis. All dimensions are in centimeter here. Okay. All dimensions are in mm. All dimensions are in mm here. It is mentioned also. And you have to find out ZP in centimeter cube. Try to solve everything now. Let us see. So we have to find out the plastic section modulus here in centimeter cube. Very simple. See, about the weaker axis is this one, my dear friend. The weakest axis is this one. See, what I will do is, about this axis I have to find out the plastic section modulus. See, ZP is equal to what, my dear friend? ZP is what? A by 2 into Y1 bar plus Y2 bar. Here I can say Y1 bar will be equal to Y2 bar. Let me call it as Y bar. So therefore ZP is equal to 2 into A by 2 into Y bar. That is, you have to find out the CG of this half area. So first of all, take the CCG of these two areas. The depth of the CG of these two areas will be at 35 mm. So what I will write? A by 2 of this area is how much? 70 into 9. Can I write like this? That is 70 into 9 into 2 into 35 mm plus this half area. This half area I am taking now, this half area. This will be how much? 280 minus 18. This will be 182. 182 into 6.1 by 2 into 6.1 by 4. Like this I can write. This will give me the answer in mm cube, but I want the answer in centimeter cube. 1 centimeter is 10 mm. So multiplied by 10 to the power minus 3. Answer will come out in centimeter cube. How much answer you are getting? Tell me fast. Like this I can calculate. So answer will come out to be 89.89. I have calculated and answer came out to up to 1 decimal place. You have to give your answer up to 1 decimal place. So like this simple questions are asked. See, 2 marks question, very simple. And generally more of the questions are asked from plastic analysis only, and they generally ask question either on the shape factor or on MP, their favorite topic, or they will directly ask the collapse load. These are the 3 varieties of question that are generally asked. So up to 1 decimal place is 89.9 centimeter cube. So here first of all answer was given by Suraj only. Very good, Suraj. Nitin, your answer is wrong, my dear friend. Then Manoj, Shushmita, Vikas and Yusuf. Very good. All of you have given me the correct answer. Any doubt still here? Shall I proceed further again? Tell me, is it okay till here? Let's see then. Shall I proceed? Okay. Now we will do certain question on structural fasteners. That is bolted and welded connections. Do this question first. Now very simple questions are asked from rest of the part. First do this question. Just I am showing you how much simple questions are asked from this part. Clear? This answer everybody know. In a steel plate with bolted connection, the rupture of the net section, rupture is fraction, is a mode of failure in tension. So everybody have given me A as the answer. This is very correct. So very simple question. Almost all of you have given me the correct answer. Very good. Mr. Purohit was the first one, then Nitin, Suraj and so on. Let's see the next question. Next question is on eccentric connection. This is the one of the most favorite question that are asked in your exam. So try to solve this one now. Please don't see PYQ, solve it honestly and then give me the answer, okay? Just don't see the PYQ and give me the answer. Honestly solve it and then give me the answer, please. Please solve this, make it fast, please. Solve this, make it fast. बोलो. Have you all solved? Let's see then. Very simple question. Clear? Let's see. 4 bolts PQRS is given to me. We have to find out the force on bolt F, P. So, how you have done? You have found out the direct force, you have found out this torsional force, FD and FT, and this will be the location of the CG of the bolt. Okay. So, just find out this R and so on. So, FD is how much? This is my FD and this is FT and this is the angle theta between this, and we have to find out the resultant force. FD is easy to find, 4 bolts are there, so 130 by 4 is equal to how much? 130 by 4 will be equal to how much? That is 32.5 kilonewton. I have solved it. 32 point. Very favorite question asked many times in your exam. Ft is what? T Ri by sigma Ri square. the R will be equal to how much here? All the bolts are at same R. So R would be the same for all. T is P into E. P is 130 into 200 into R will cancel. So summation of 4 into R. R will be how much, my dear friend? This is 50 square root of 50 and 120. Square root of 50 square plus 120 square. This is R here. How much FT you are getting? Tell me fast. Like this only you can calculate. So what is the FT you are getting here? Tell me fast. That is 50 kilonewton. Now FR is equal to how much? Summation is square root of FD square plus FT square plus 2FD cos theta. This is square root of 50 square, or R is equal to how much here? R is actually equal to square root of 50 square plus 120 square, that is 130. Okay, correct. Now we have to calculate FR. Cos theta is this angle. This is the angle theta here. So cos theta is FD square is 32.5 square plus 50 square plus 232.5 into 50. Cos theta will be 50 divided by 130 square root. FR I have calculated like this. It will come out to be how much? That is 69.327. 69.327 kilonewton was the correct answer. Like this you can solve this very simple question. Nearest answer would be B here. B was the nearest answer here. Okay. Okay, B was the nearest answer here. Suraj have reported first, then Vikas, Nitin and so on. Let's see the next question then. Solve this one as well. Very beautiful question on welding. Please try to solve this. Please try to solve this question as well. Make it fast, please. This will be actually 2 marks question. Try to solve this question, please. Let's see. So a weld is used for joining an angle section ISA. We can see CYY was given to me to a gusset plate of thickness 15 mm to transmit a tensile load. The permissible stress in the angle is, and the permissible shear stress on the section through the throat of the fillet weld is given to me. The location of the centroid of the angle was given to me. CYY is given to me. The area of cross section of the angle is this. Assuming the effective throat thickness of the angle to be 0.7 times the given weld size, that is 0.7 s, the length L1 and L2 of the weld required to transmit a load equal to the full strength of the tension member are. So strength of the tension member I can always find out. You don't have the gross area here, so you can find out the gross area of the section was given to me. So first find out the tensile strength of the member, that is governed by yielding criteria. Okay. So design strength of the member. This whole load will be transmitted sigma permissible into gross area, that is 150 into 150 into 1903 into 10 raised to power minus 3 kilonewton. So this is the tensile strength of the member. Tensile strength of the member, how much you are getting? I have calculated it, that is 285,450 kilonewton. 285,450 kilonewton. Now you have the angle member here. One is L1, one is L2. See here the force that is being transmitted here, this would be, let me say P1, and this would be P2. We have to find out P1, P2 here. One thing you should understand, that there should be a moment free connection. So P1 plus P2 is equal to T, 285,450 clear kilonewton, and for moment free connection, I can say P1 into CYY is equal to P2 into 100 minus CYY. This implies P1 into CYY is how much? CYY is how much? 28.4. P2 into 100 minus 28.4. This implies P1 by P2 ratio. So from here I can solve P1, P2. How much you are getting P1, P2? Tell me fast. That is 71.6 by 28.4. Now from equation 1 and 2, what I can write? P1 is equal to how much? P1 is equal to, P1 is how much? P1 is equal to how much? I have solved it. P1 have came out to be P1, P2 I can calculate here. How much you are getting? Tell me fast. Or instead of calculating P1, P2, one more thing I can do here. See, I have to find out length L1, L2 na. The lengths L1 and L2 rounded off to the nearest integer. So we have 4 options were also there. Okay, there were 4 options. You have to report your answer A, B, C, D, so on. You might have solved it. So just report your answer now. L1, L2 you have to find out. First you have to report L1 and then L2. So first find out P1, P2. So P1, how much you are getting? Tell me fast. What is the value of P1 you got here? Tell me fast. Once we get P1, I can easily calculate the value of P2. L1, L2. So P1, P2, how much you got? Tell me fast, please. Have anybody calculated P1, P2? Tell me fast. Have anybody calculated P1, P2? P1 is 20438, 2.2 kilonewton. And P2, how much you got? 81067.8 kilonewton. Once we know P1, P2, just we have to calculate the value of length now. Length I can easily calculate. Permissible shear stress in the weld was given to me. That is how much? That is, and size of the weld is also given to me. Weld size is how much? The given weld size 15 mm gusset plate, 5 mm weld. Size of the weld is 5 mm. So can I write like this, that P1 will be equal to sigma permissible weld into what? Into K into S into L1. So L1 is how much? Or P is this one. P is into this. So L1 is equal to 204,382.2 upon sigma permissible of the weld, that is tau permissible, or instead of sigma you can write it as tau also, because this is shear stress. Okay, instead of sigma I can write tau permissible of weld as well. Okay, so tau permissible of weld is how much? Tau permissible of weld is how much? It's equal to 108 K is 0.7, S is 5 mm. So how much you are getting? L1. L1 from here I can calculate. L1 is equal to how much? L1 is 540.68, I guess. Please see. And similarly L2 I can also calculate, that is 81067.8, 108 into 0.7 into 5. That will come out to be 214.472. Very beautiful question on welding. So this type of questions also you can expect, that is a question on a moment free connection. So for moment free connection, total moment should be 0. So from here accordingly I can calculate. Clear? So correct answer is 540 and 214. 541 and 214, that is nearest answer is A. Whoever have given me A as the answer is very correct. Okay. So almost all of you have given me the answer. A is the correct answer. So like this you can solve the question. Very simple. Okay. Now let's see one more question on welding, that is eccentric connection using welding. Please solve this question as well. Make it fast please. Everybody solve this question. So by what we have to find out? We have to find out the maximum resultant stress, that is the equivalent stress. Resultant stress here means what? Equivalent stress. So here we have to find out the equivalent stress here. So equivalent stress is, we know what is equivalent stress. Fe is equal to square root of Fa square plus 3Q square. So first find out the direct shear stress here. Two welds are there. Of size how much? Weld is of size how much? So 350 kilonewton load was, size of the weld is 10 mm. So throat thickness is how much? 0.7 s, that is 0.7 into 10, that is 7 mm. Q is P by 2 into dTt. Okay, so my load is, factored load is how much? Point load is how much? 350 upon 2 times. Depth of the plate is how much? 150 mm, 500 mm into throat thickness is 7. So your direct shear stress will come out to be how much? That is, direct shear stress is coming out to be 50 MPa. Direct stress is how much you are getting? Direct shear stress, that is 50 MPa only. Please check the answer. 50 MPa only, I guess. Direct shear stress how much you are getting? Into 10 to the power 3 also. Okay, you have to report your answer in MPa. So this is 50 MPa. Similarly, Fa is what? My by I. Moment is how much? 350 into Newton into eccentricity of the force is how much? That is 100 mm. Y is how much? You will take the moment about this here. So Y will be d by 2, that is 500 by 2. I is how much? 2 into Tt, that is 7 into d cube by 12. So by what is the bending stress you are getting here? That is 60 MPa. Now my Fe will be how much? Square root of 60 square plus 3 into 50 square. Like this only you have done. Yesterday I also told you that like this you can find out the equivalent stress, that is 105.35 MPa. So this kind of questions you can very much expect in your exam. I can see Vikas, Suraj, Yashashvi all have given me the correct answer. Very good. Like this you can calculate the equivalent. This is a very standard question asked many times in your exam. So these are the questions on fastener. Now let's see one more question on tension member. Try to solve this question, please. Make it fast, please. Try to solve this question. Give me the answer, please. Make it fast. Clear? A steel member M dash has a reversal of stress due to live loads, whereas another member N has reversal of stress due to wind load. As per the maximum stress ratio permitted is. So obviously, if the reversal is due to live loads, the slenderness ratio, the maximum stress ratio for M dash would be less than as compared to member N. Okay. So for member M, the permissible strength ratio would be less. For M, generally the permissible strength ratio is 180. Lambda max is how much here? Lambda max is 180, you remember? And for tension member, here it is, I guess, 300 or 280. You remember the number? So I can say that lambda max for N would be more. So less for member M and then that of member N. So yesterday only we have seen this. A is the correct answer. N is 250 for compression member and 300 I guess for tension member. Okay. So correct answer would be A. So for member A, the maximum strength ratio for member M would be less and maximum strength ratio for member N will be more. A is the correct answer. Okay. Whoever have given me A as the answer is correct. Mr. Purohit, Yashashvi, Nitin and so on. Very easy question. Let's see few questions on compression member now. Please find out this question as well, this answer as well. Make it fast please. These type of questions you can very much expect in your exam also. You have to find out the non-dimensional stress ratio here. Lambda bar you have to find out. How do you calculate lambda bar? You already know. Make it fast. Solve this question as well. Simple questions are asked from this topic. Make it fast please. Few more questions I have to show here. See, these are the type of questions you can expect in your exam. So don't worry much in your exam. Very simple questions are asked, my dear friend. So lambda bar you all know how to calculate. How to calculate lambda bar? Lambda bar is Fy by Fcr square root. Square root Fy by Fcr, that is square root of Fy. Fy is 250 upon Fcr. Fcr is the critical stress. Critical stress is how much? Critical stress is not 1000, it can't be 1000, it will be I guess 1000 MPa only. So critical bending stress is, okay, it's 1000 only. 1000 only. So FCR is 1000 was given to me. That's correct. Critical bending stress is 1000. So how much answer you are getting? But critical bending stress, okay, it's a short column. It can be greater than that as well. So lambda bar will come out to be lesser than 0.2 I guess. So square root of 1 by 4, that is 0.5. Okay, it's less than 1. Okay, lambda bar is less than 1. Now for lambda bar less than 1, your FCR can be greater than Fy. Now data is correct. So 0.5 is the correct answer. So A would have been the correct answer. So like this you can calculate the value of lambda bar. That is a non-dimensional effective strength ratio. A was the correct answer. Almost all of you have given me the correct answer. Very good. Next question, few more questions I have to show you. Effective length factor of column R. So tell me the answer of this one as well. A steel column is restrained against both translation and rotation at one end. So at one end it is fixed, on the other end only it is restrained against rotation, not against translation. So here you have slider support. Here you have what? Slider support. Okay. So the deflection would be like this here. So if this is L effective will be equal to what? K into L. K is equal to how much? Theoretical value of K as well as per IS code. So as per IS code, the theoretical and design value we have to tell. So design value is how much? Design value K is equal to 1. Theoretically is 1 and for design it is 1.2 as per IS code. Like this only you will solve the question. So correct answer is what? So as per IS code, theoretical value is small, and for IS code it is more to account for lack of fixity. So A is the correct answer. So if you are giving me A as the answer, this is very correct. 50% of you have given me only Nitin have given me the correct answer. Okay. So here Yusuf also given me the correct answer, Yashashvi and so on. Many of you have given me the correct answer. Very good. These are the type of questions you can expect. See, effective length I have taught you yesterday also. Write down the answer of this one as well. Make it fast please. And then I will show you the last question of the evening. So square root of moment of inertia to area of cross section. This is what? Radius of gyration. This is known as what? Radius of gyration only. Second moment of area is moment of inertia only. So this is radius of gyration, that is D is the correct answer here. So if you have given me, so all of you have given me D as the answer only, hai na? D is the correct answer, okay. D is the correct answer. Almost all of you have given me the correct answer. Last question of today's session. Please tell me the answer of this question as well. Last question of today's session. Think before answering. So give me the answer of this question as well. I want correct answer from everybody. The elastic critical stress in compression increases with decrease in strength ratio. This is correct. We know FCR is equal to pi square E by lambda square. So if lambda increases, FCR would decrease, and FCR would decrease, or FCR would increase if lambda decreases. Very correct. First state, the effective length depends on the boundary condition at its end. That is also correct. The elastic critical stress is independent of strength ratio. This is wrong. Third statement is wrong. So A, B, C can't be the correct answer because third statement was wrong. Third statement is wrong. Ratio of the effective length to its radius of gyration is known as strength ratio only. So fourth is correct. 1 to 4, that is C. This simple question was asked in exam. The simplest of all. D is the correct answer, my dear friend. So almost all of you have given me the correct answer. Very good. So you can see that in steel, very tough questions are not asked. Questions are very simple. Plastic analysis, I have already discussed all these questions. This was repeated here anyways. So in steel, you can see that the nature of question is very simple. I have shown you the level of question that was asked in exam. Now we will meet again at 7 p.m. There we will see more questions on different concepts, the newer ones. So let's meet at 7 p.m. in the Mahabhyas session. There you will see a newer variety of the question. Okay, so let's meet at 7 p.m. again. Okay, bye bye everybody. Take care.